only one perfect solution, but there are clues that will try to trick our team.
Hello there, everyone. My name is Crazy Caleb, and today we're going to be taking a look at a fairly simple module, but an interesting concept, decimation. So this is the way the module looks. It's a little bit of a broken apart module, and it's very easy to tell apart from pretty much any other module. The funky text, the parts of the module actually missing, and you can see the back of the actual bomb, and just the way that it looks. So what we're going to be doing is we're going to be doing a series of weird multiplication / additions rules, and what it is the module consists of 3 stages total, and there will be two two-digit numbers on the large display, as we can see here, and a little operator sign right here. That will be either between addition or multiplication, which addition is marked with the plus, and multiplication is marked with an asterisk. You'll see what I mean later on. So we're going to perform the operations on the 2 numbers and submit it into the keypad. There will be 3 stages total, as I mentioned. The first stage will always be addition. That's the rule that you will be simply applying for that rule. And the second stage, next up, will always be multiplication by a single digit. Then the third stage, finally, will always be multiplication. That could be either by a single digit, but most of the time you'll end up actually doing double digit times double digit. So you think this is normal math, right? This is not normal math, unfortunately. And it says here, however, this module's evidently faulty mechanics caused the module to use an altered arithmetic system. This is referred to as dismal addition or multiplication, or lunar addition or multiplication. As it says here, this module uses dismal arithmetic, also known as lunar arithmetic, to perform its operations. So now, the concept of lunar addition and lunar multiplication. Lunar addition, let's take these numbers here, because the first stage is always going to be addition. Lunar addition or dismal addition is the variant of the standard addition in which, when adding 2 digits, the result is the higher of said digits. So, taking a look at 0, 0, so we have 0, 0 plus 5, 9. And this is the way that we're going to set it up. So 0, 0 plus 5, 9. What we're going to do is for each individual position on the actual numbers here is we're simply going to take a look and compare each of the digits in the 1 position and each of the digits in the 2 and the tens positions. So what we need to also do is we need to figure out with those individual digits which one is higher. So for our first position, being in the ones, 0 and 9 are being compared here. 9 is the higher digit, so we're going to use U. Similarly with 5, 0, 5 is the higher digit of a 0, and simply what we're going to submit into the module is 5, 9. Now, me explaining this did really nothing because 0 plus 59 is 59, so just you got to take my word for it. But essentially, what it is we are simply we're simply comparing each of the digits in the same position and taking the higher of the ones. So we have 59. We're going to hit these into the module. It will display right down here, and we're going to hit this guy as our submit button. All right. Next up, as I said before, it now changes to an asterisk, and the stage counter up here in the top left moves 1, and it fills up a triangle. So now we're taking a look at addition. So our number we have is 34, and we're going to multiply this by 0, 7. All right, so now let's take a look. So now, decimal multiplication is a little bit of a weirder concept to understand. Decimal multiplication is a variant of standard multiplication in which multiplying 2 digits, the result is the lower of the 2 digits. I'll explain what this means, and you can also use these examples down here to give you a better idea of what we're looking for. So it's going to be similar to addition as the way that we compare numbers with one another. However, the way that we do it is actually a little bit interesting. So what we're going to do is, since we're multiplying with 1 digit each time, multiplying with a single digit, what we're going to do is we're actually going to use this little 7 right here on its own. I'll get rid of that 0. What we're going to do is we're going to compare the 7 with each of these numbers, both the 4 and the 3. And what we're going to do is we're going to figure out the result of the lower digit. So 7 compared to 4, 4 is the lower digit, so we're going to mark that for the ones place. And then the 7 compared to the 3, the 3 is the lower digit, so in this case, that's going to be marked for the 3 in the tens position. And we're going to submit 3, 4 into the module. All right, and now for the third stage, it will always be multiplication, and as you can see, it's going to be a 2 by 2. So what exactly do we do with 2-digit numbers times 2-digit numbers? So this should be pretty simple enough to explain. However, here's where things get a little bit interesting. So we have 52, and we're going to multiply this by 19. So now what we're going to do is we're going to do the same thing that we did using the ones digit first, comparing these 2 numbers that we're multiplying by. So 9 and 2 2 is going to be the lower one here. And 9 and 5, 5 is going to be the lower one here. So we're going to use that for our first number. And now what we're going to do is we're going to do the same thing, but with the 1. And we're going to do it in the tens position. So what I'm going to do is essentially take a step back to mark it as the tens position. So I'm actually going to create a little line here to separate this. So this is this 2 will count as the ones position here. The 10, or the 5 will count as the tens position. And what's going to happen here is I'm going to do the tens position first for the 1 and the 2, comparing these two. The 1 is the lower value here. And then what I'm going to do for the 1 and the 5, the 1 and the 5, we're going to take the lower value, being 1 in this case, and this is going to go in the hundreds position. And this is the way that the module should be structured. So now what we're going to do is we have 2 numbers here present, and what we're going to do is we're simply going to do lunar addition with this case, with these 2 numbers here. So decimal addition, we're going to take the higher value of the 2 digits. We've already done the decimal multiplication, which we've got our 2 values from here. And now what we're going to do is going to go from left to right and figure out which one is the higher of the 2 digits. So 1 compared to nothing else, well, that already has to be 1, guaranteed. 1 compared to 5, that gives us 5, because 5 is the higher number compared to the 1. And then 2 is going to be the only number by itself in the ones position. So our answer for this stage is going to be 152. Submit this into the module. And just like that is a solved module. So hopefully that concept makes sense. It's a little bit tricky to explain, but hopefully it makes sense. It's essentially you're doing lunar multiplication, or decimal. I just refer to lunar multiplication because I'm more used to it. It's more mentioned in other manuals compared to decimal. So you do lunar multiplication, and regarding to each individual digit, taking the lower value, getting two numbers here, and then simply doing lunar addition with it. So hopefully that's fair enough to understand. Hopefully that makes sense. And now let's take a look at some other examples here. So remember, our first stage will always be addition. So 32 plus 81, comparing each of the digits, we need to take the higher one. So 2 is the higher of the digit here. So 2 is going to be in the ones position. And of the 3 and the 8, 8 is the higher one. So we're going to submit 8, 2 into the module. All right, on to the next stage. We have 19 times this by 2. All right, and now what we want to do is we want to take the result of the lower digit. So comparing 9 and 2, we want to take the lower one. So in this case, that's going to be 2. And then 2 and 1, comparing 2 and 1, that's not what I wanted to do. Comparing 2 and 1, what we're going to do is 1 is the lower digit, so we're going to put this in the tens place. And now we're going to submit 12 into the module. All right, on to the next stage. So next up, we have 0, 6, which actually is going to be pretty nice. And we're going to multiply this by 19. All right, so now using the 9 first, what we're going to do is we're going to take the lower digit to create our first number. So we have 9 and 6. 9 and 6, the lower one's going to be 6. And between 9 and 0, 0 is going to be 0. So our first number is going to be 0, 6, based off of the 9, comparing the numbers to the 9. Next up, we're going to compare the numbers to the 1, starting in the tens position for this time around. 1 and 6. 1 is the lower number, so we're going to do 1. And then for here, we simply have 1 and 0. 0 is the lower position, so our next number is going to be 0, 1. And now we're going to do lunar addition. So 0 compared to anything else is 0. 0 and 1, remember we're getting the higher of the digits, so we're going to get 1. And then 6 compared to nothing means 6. And obviously it doesn't want us to do leading zeros because that doesn't mathematically make sense. And for example, if we were to submit 0, 6, 1, 0, 1, or 0, 1, 6, we actually wouldn't be able to do that at all. If we were to submit 0 first, it would simply just cancel that out and just place in the next numbers. So all we would have to do is submit 1, 6 into the module. And just like that is a solved module. I'll take a look at one final example. Hopefully you've understood the concept of how this works because it actually took me a while to learn this myself. So addition is going to be comparing the 2 digits, taking the higher one. 7 and 0, 7 is the higher one, so we're going to take U. And then 8 and 4, 8 is the higher one, so we're going to take U, giving us 8, 7. All right, next stage. 28 times this by 3. Comparing 3 and 8, 3 is the lower one. So we're going to take 3 for the ones place. And comparing 3 and 2, 2 is going to be the lower one, so we're going to take that for the tens position. So 2, 3 is going to be our answer. All right, last stage. 36. Multiply this by 87. And taking a look here. So we have 7 and 6. 7 and 6. 6 is the lower number here. 7 and 3. 3 is the lower number here. And between 8 and 6, making sure that we go to the tens position. 8 and 6. 6 is the lower digit. 8 and 3. 3 is the lower digit. Rather quite nice. And now doing lunar addition for the what we have here. We have 3, 6, and 3, 6. So 3 compared to nothing is 3. 3 and 6, we're taking the higher digit, so that's going to be 6. And then 6 compared to nothing is going to be 6. And our answer will be 3, 6, 6. And just like that is the solved module. As always, thank you guys for watching. If you have any questions, please leave a comment. As always, stay crazy, stay cool, and I'll see you guys in the next one. Bye-bye.